Alrighty, why don't we get started? Just wanted to welcome everybody to the Nova demo today for printing wearable electronics. Before we jump into the demo itself, I'm just going to go over the plan for the next hour or so. So today we'll be printing with Celanese Intexar PE874. Some of you might know this as formerly as DuPont, but this is a silver stretchable conductive ink, and we're going to be printing that onto TPU, which is also a stretchable substrate. This is going to be a pretty representative example of how you could use Nova to prototype wearable electronics. So the main focus for the demo today will be on calibrating the ink, just showing you how to go from a brand new ink to being able to print with it. And then, yeah, once we complete that calibration, we will be printing onto our TPU substrate with a wearable design. Yeah, at the end, we should have plenty of time for questions, but feel free to post any questions in the chat throughout the presentation. We've got Roy and we've got Tom in there as well. And they'll be able to pop in and answer any questions you have throughout the presentation as well. And they'll be trying to filter anything to me that seems notable in the moment. Perfect. So yeah, without further ado, let's just jump right into the software and get printing. Awesome. So this is the Nova software. If you're a former V1 user, this should look fairly familiar. The layout, we've got the three workflow tiles directly in the center of the screen, the dispense, the materials, and the calibrate. But yeah, we're just going to jump right into the calibration workflow since we're looking to calibrate our new material, the PE874 from Celanese. Awesome. So much like the V1 as well, kind of all the actionable stuff you're going to see on the screen is up on the left-hand side. And the work area is just going to be kind of in the center of the screen. So the entire process is fully guided in the software. So it's really easy from your first time to your 100th time. Yeah, it's just going to walk you through everything you need to do the calibration. But we're going to start with a new material. So we're going to give it a name, PE874, and I'm going to give it a nozzle size just so I remember for the future as well. And then I'm just going to select the category. In this case, it's a paste. I'm going to choose the type. We're working with a conductive paste today. And then it's silver based. So this is just some added info for when we add it to our library, when we're filtering between some of our other materials. I'm just going to add a quick note as well. So that I've got just a little bit added context in the future. Awesome. Now that I've got that all dialed in, I'll just hit create. Perfect. And you can see our paste has been selected that we just added, and we're ready to continue on. Awesome. So the first step is we're going to be probing the calibration plate. So Nova notably has this large calibration area in the front, and this is purpose-built, so you don't have to do your calibration directly on top of your substrates in your work area. You've got a nice kind of clean, sterile environment to do that calibration on its own. So you can see the calibration plate is this pill shape, and that's represented on our screen here as well. And we're going to start out by probing our calibration plate. So I'll just hit probe. And we can see Nova is taking the probe and interacting with the XYZ positioner tool. So right now it is working on finding itself in three-dimensional space. So it's interacting with all sides of the XY positioner tool, as well as the top to find the center of the probe tip. Yeah, and this is something that you're going to see a fair bit today. Both the probe and the dispenser are both going to be doing this just about before every kind of action they need to interact with. Perfect. And we can see Nova's working through the probing points right now on the calibration area. And in our software, we can see the probe points working itself along kind of in real time. So once a point has been probed, it's filling in the circle with a solid blue circle. Now, we're not expecting to see any errors today, as this is a nice and clean surface, but if there were any errors, they would pop up as a red solid circle and let us know what the reason for the error is. So the other, I guess, notable thing with the probing points is, yeah, we didn't probe that much across the entire surface of the calibration plate. And so what's happening is we're basically creating triangles and then interpolating the data in between those triangles to create the full height map. So we found kind of this pitch between the probing points as a good balance between speed and accuracy. But in this case, we are all set. We've got no errors, and we're good to kind of move on here. Perfect. So now we're going to start select our target quality for this ink. So by just kind of the basic settings here, we can select the nozzle we're using. Today, I'm going to be using a 100 micron nozzle. But if we open up the advanced settings here as well, we get a few more parameters we can work with. So we see the nozzle diameter set here. We see a trace width, we see a print height, and as well as a temperature. And at the bottom, we get a little bit of a graphical guide to whether our print settings are fairly realistic or not. So with our nozzle diameter of 100 microns, it's by default giving us a print height of 40 and a trace width of 120. Now, if I were to increase this drastically to like 300, for example, that's going to be really difficult for our nozzle to dispense in one pass. So we get this notification and a visual representation that we should probably consider decreasing this trace width. Similarly, I'm just going to restore this to the default. If I were to drastically increase the print height here to let's say 90, again, it's saying consider decreasing the print height. It's fairly unrealistic for the ink to be able to print in this type of shape just on how it dispenses. But yeah, I think I'm pretty happy with the defaults that we were given today. And I guess I'll just give one note on the temperature, the reason why that's there. So the dispenser itself on Nova heats up, and this temperature was selected because it's not a typical room temperature. And so we wanted to give a temperature that the dispenser will heat up to every time. That kind of eliminates the change in temperature from your lab variance, basically. So we're trying to eliminate that as a variable so that every time you go to print, the print settings are going to be consistent with the temperature of the ink that it's going through. Just saw a question come in. Could you print with a much lower height, say 10 microns? 10 microns is probably going to be a little on the low side. I'd say with Nova, you're probably good printing around the 30 micron height and above. Now, that being said, you can see we have two tools on Nova right now. There is going to be a variance in the height from port to port between the two tools. So anything like really below around 40 or 50 microns, you want to start considering using just one port and using the tools swapping back and forth just on that one port, because that'll help eliminate that port-to-port variance and just give you better tolerances. Perfect. So in this case, I've already prepared the dispenser, but we've got some great instructional videos here on the right-hand side of the software that take you through how to assemble and disassemble the dispenser itself. We've also got a great guide in our support docs at docs.volterra.io. And yeah, you can check that out anytime as well. But we'll just click next here. So like I mentioned before, Nova needs to heat up to dispense the ink just to give us consistency with our print settings. And so we can see it's working its way through heating up right now. Yeah, somebody just mentioned that it looks like Nova is primarily for prototype work. Yeah, I mean, that is the main focus for Nova as a tool, is to help you with the prototyping process to speed up the process drastically. So yes, you're right. It's mainly focused for prototype work, although we do have a couple of users using it for some smaller scale production work where they're doing yeah, just kind of need to do prints in the hundreds, and moving over to screen printing just wasn't financially didn't make sense for them. All right, so we are fully heated up here. So I'm just going to go ahead and hit check for the pressure estimate. So what we're doing here is we are just getting a baseline starting point before we start the calibration procedure. And we just want to know what is a good kind of starting pressure to get a rough start for our calibration process. So we can see Nova, the dispenser, interacting with the XYZ positioner tool, much like the probe did. And then once it is done there, it's going to head over to the flow check circle over here. There's nothing fancy with this circle. It's just a place for material to be dispensed above, so that we're not getting any other area messy. I'm just going to put a wipe above it, just to make cleanup a little easier for myself as well. So what I'm looking for is just material to come out the tip of the nozzle. And as soon as I see material coming out, I'm just going to hit stop. And that'll be our starting point for pressure. All right, so I can see a droplet. It's probably not easy to see it on camera, but I'll take it off there and you can see I've got a little droplet there. Perfect. And you can see just in the grayed out area here, we've estimated a pressure of about 700 here. So we are good to move on. Perfect. So the calibration process, I'll kind of explain it as it's printing its first pass, just because it takes about a minute. But I'm going to hit print here. And basically what's going to happen is Nova is going to print this calibration pattern right here. And once it prints that calibration pattern, it's going to go and take a picture of it and let us inspect it. And then we're able to mark it and basically give it a grade for how we think it looks. We've got a couple of parameters to grade it with: width, pressure, leakage. We've got starts and stops under the advanced settings here as well. But yeah, based on these, how we grade the calibration print, it's going to then adjust the pattern settings, and we will be able to print again based on our grading and see if there's any improvement. So Nova's working its way through the first print here right now. Perfect. And then Nova's going to jut forward and grab a picture for us. And we can see that picture came up. And we're able to zoom as we hover over with the mouse. And in general, we're just looking for fullness in the traces, but separations between them, especially in the lines. And then we want to see some uniformity just with the traces and the corners. Now, this is a fairly runny ink in the first place, and it was newly packed today. So the four smaller squares here, I'm probably not going to expect to see the separation between them. And this is a great point to point out that the target settings that we put in aren't going to be always obtainable with the ink you're using. So you do want to be realistic with the targets that you set, that they make sense for the type of ink you're working with. Yeah, so yeah, let's go ahead and start grading this. So for pressure itself, I am seeing some good separation here. I might dial it back just a tad, just to see how that looks for us. And if you're ever unsure of what this the setting is that you're grading, you can always hit the little question mark beside it, and we get a little definition and what decreasing and increasing are going to do for that setting. So for leakage, let's take a look at that as an example. So leakage or oozing can occur when traveling, resulting in excess paste dispensed. So we would decrease this to reduce blobs at the starts of traces or between traces, and we'll increase this if we see that the piston is retracting excessively. So the piston we're talking about is just this guy right up here. So if we see it backing off an extreme amount in between prints, we will adjust that setting accordingly. Somebody just asks, will the V1 have a wearable printer option added? Currently, I don't think that's in the works, although we always take your feedback, and we love to get that and use that as our product roadmap going forward. So if that's something you'd love to see, let us know. But yeah, right now the V1 is kind of the all-in-one rigid substrate prototyping tool. And Nova is really focused on flexible hybrid electronics. Cool. So I'm just going to jump back to the leakage setting here. So decrease to reduce blobs at the starts of traces. So yeah, we've got a little bit of blobbing here, but again, this is a pretty runny ink. So I might just decrease the pressure to see how that affects the setting. So I'm just going to hit improve, and we'll print another pattern. Now you notice I'm not immediately wiping down the calibration plate. Nova's smart enough to know to print the next one right next to the previous version. And we can see that highlighted in the bottom corner here. It's just going to print the next pattern. So we've got room for a good number of calibration patterns before we need to clean the plate here. Just give you a view of Nova printing again here. And here you can get a kind of a good view of the piston retracting in between features as well. So it's usually turning green when it's retracting. Perfect. We're grabbing our picture, and we can see the picture show up here. Okay, so maybe backing off on the pressure wasn't what we wanted to do. So I'm going to increase that again so we can get back to where we were. And I think I saw the piston retracting a little bit, so I'm going to increase this by 2, and we'll see how that improves things. Perfect. So we're just printing our way right now. Yeah, we've got a question in the chat while it's printing as well. Can I prepare ink in my own lab, especially if I want to prepare an ink based on some conductive materials that I already have in my lab? And yeah, this is absolutely the case. Yeah, we've specifically designed Nova to work with a multitude of different materials. So more or less, as long as it's screen printable by nature, Nova should be able to dispense it. So yeah, that's why we developed this calibration process as well, the workflow in the software. So you can be packing and printing your own materials. And we use the 5cc Nordson cartridges inside Nova's dispenser. Awesome. So we're able to see with our calibration pattern here, we were getting our flow right back. So that's really nice to see. Yeah. And I mean, We've got a little bit of blobbing here, but I think for the sake of today's demonstration, these settings would probably be good for the application we're going to print. We're not printing anything with anything. There's no really tight pin pitch or any traces that are very, very close together. So we're going to be able to get a good result for our print with these settings. So once I'm happy, I'm able to hit use and we're able to continue on. And you can see it's dialed in the settings here for us. So with only a couple of grading criteria, we were able to come up with these 10 different print settings for this material. And once I hit finish, it'll be saved into my user settings as well to be used at any time. So if I come back in a week and want to print with this ink, I can grab those again. Now you'll also see the other thing it's recommending I do is just to wipe the calibration plate right now. And we get a good help walkthrough of how to do that. And yeah, the calibration plate just pops up and then I'm able to wipe it off. So I'm just going to do that quickly off screen because we're going to need the calibration plate again in our next step. But yeah, in the meantime, I will just hit finish. Yeah, we've got another question in the chat as well. Yeah, is there any way to extend the advanced calibration settings to include things like height and feed rate? So far, I've been able to do that by dispensing a collection of self-made calibration patterns on a substrate, hopping back and forth between dispense mode and the materials library to adjust those features sets. So yeah, that's great feedback for us to think about when we're thinking about the calibration pattern. The height itself was one of those target quality settings. Set for a second there. The current way would just be to kind of jump back, adjust that height, but the feed rate, that's a great suggestion on your end as well. The current way to do that, I can show in the next step when we're in the dispense mode where those settings exist. And all those settings can be adjusted on the fly when you're dispensing as well. Perfect, but yeah, now that we've finished up our calibration, and my calibration plate is clean, we are ready for the next step to move on here. So we're going to jump into the dispense workflow now. Perfect. Yeah, so I mean, we've got a great question as well. What kind of substrates can we use? Yeah, anything flexible and rigid. So I'm just going to home the machine so I can access the print area. So Nova comes with a vacuum module here, and it is porous titanium. So those pores help us use the vacuum to create an incredibly even suction across flexible substrates like PET or TPU or like a polyimide. But when we remove the vacuum bed, we've also got a 40 millimeter by 40 millimeter grid here that you can use to screw in custom made hold downs for like rigid substrates. We also have our own set of rigid substrate hardware that screws in there as well. So you're able to use traditional like PCBs, 3D printed parts, whatever you like there. So it's quite flexible for the types of substrates it can work with. Perfect. So for today, we're going to skip the create a job section. This is really used for jobs that you're going to do repetitively over and over and again, just to save your circuit and your ink and your substrates ahead of time. But yeah, we're going to jump in right into choosing our materials. So we're going to use the ink we just calibrated, which is the PE874 with the 100 micron nozzle. And then we're going to print onto TPU. And now that they're selected, we can just hit next. And yeah, before I forget, I'll just show you the print settings. So I went up to the settings cog at the top, and we can see our print settings here. So if I wanted to adjust the print speed, I could do so here. dropping it down to 400 millimeters per minute. But yeah, the default right now is 600. And then you can just hit save whenever you're done. Similarly, you can adjust the settings for your substrate as well. We are going to choose a file. And the file is just going to load in here. And as it loads in, Nova is working on generating the tool paths for the Gerber file. And currently, Nova, we accept Gerber files, and we also have SVG in a beta program right now. So if you have a Nova and you're printing, feel free to start using some SVGs and give us some feedback on how those are loading for you as well. Awesome. So our pattern loaded in, and it turns green once it has the toolpaths figured out. And if you see, I can zoom in real close and we can see those toolpaths. Yeah, we'll just zoom out, and yeah, everything looks just like what we were going to print. So we're able to move on to the next step here. So now we're going to mount our substrate. So I've already got our vacuum module in place. So I'm just going to grab my sheet of TPU. And then I'm just going to make sure that it looks nice and clean, dust-free. It's good to wipe it down if needed. But yeah, the margins that we're printing with the 40 micron height, even a speck of dust that gets caught in there could cause an issue with our print quality. A speck of dust is anywhere from 20 to 50 microns oftentimes. And yeah, how we would see that is just a section of the print trace would probably be left out. But yeah, our substrate is mounted. So we're able to start estimating the alignment. Now for today, we're just going to kind of print right in the middle, keep it nice and simple. So I'm just going to skip through this, but our next webinar, we're going to be focusing heavily on the alignment step. But yeah, again, I'm ready to start probing. So I'm just going to go ahead and do that. And we're going to measure the probe again. Now, the probe is going to probe both our substrate as well as the calibration plate, because we're going to do a flow check in a minute on the calibration plate before we start printing our material. So it's just going to probe both. There we go. So it's found itself in XYZ. And you can probably hear through my mic now that Nova is interacting with the substrate, it has turned on the vacuum module automatically. So if I try and move the TPU in the background here, it's not going anywhere. It's well adhered to the surface, very evenly too. All right, so again, Nova's just probing through the calibration plate. And then it's going to shoot back to our substrate itself and start probing there. And if I jump back to the software again, we can see the probing points turn blue or fill in blue once they have been probed. And we also get a progress bar over here in our steps section, letting us know how far along we are in the probing. We got a question about what are the supporting Gerber formats. We stick really closely to the Gerber standard. So we've got a full section in our support docs on what those standards are. And if you ever have any issues with your Gerber files, you can always reach out to our support team, and we're happy to work through those settings with you and get you all sorted out. All right, and we are nearly done probing here. Just the last few points. And then we'll move on to the flow check. We have a question about, can it print onto a super flexible material? Yeah, somewhat of a loose definition of super flexible there. But I mean, the material we're using right now, the TPU, I would say is a very flexible substrate. So yeah, absolutely, it can print onto super flexible materials. We've printed onto some paper and fabric as well. So that's a great example. I'm not sure if it's coming on camera here at all for you. I don't think it is, but we've actually got a big speck of dust in this back corner here. Maybe if I shine a shadow. Yeah, I don't think we're going to be able to capture it, but yeah, that would be a great example of what dust looks like under our TPU. But it's not in the area we're printing, so we are all happy. And we would have likely seen the error pop up here if we were probing onto a speck of dust as well. But we're able to move on here. Again, our dispenser has already been prepared, and it's attached. So I'm good to just skip this step. It's all set up, and we're going to go right into the flow check. So the flow check is not a calibration. We've already done the calibration. Nova already knows the settings for this ink since we selected it. So all we're doing here is just priming our dispenser to make sure that ink is flowing out before we start printing our pattern. That way we just get a nice successful print on our first trace, and the ink's ready to go for us. We've got some questions about which PCB design softwares are recommended from Volterra. In-house, we use Eagle for most of our designs. But yeah, we've got some design guidelines for some of the major ones out there, like Altium and KiCad as well. So yeah, there's kind of options for everyone out there, whether you need a free solution like KiCad or a great tool set like Eagle. So Nova is just working on printing those 3 lines as we can see indicated here in the green. Once it prints those lines, it's going to grab a picture and we're going to see if the ink is flowing. We don't need to see all of those lines in full, but we just want to see that that ink is flowing again. But in this case, it looks like, yeah, we've got all 3 flowing. So I think we're ready to go. So yeah, we are good with the flow check. So I'll just hit next here. Now, if we notice anything funky happening during our print, like we need some more ink or ink is pulling a little too much while we're printing, we can adjust the dispense and relief settings on the fly here. And we're able to toggle how much we're adjusting them as well. But in this case, I'm just going to hit start and we'll see how things are looking. We've got a question about whether we're sending out a recording after. And yes, we will be sending out the recording tomorrow in an email as well. Perfect. And so I'll just zoom in on Nova working through it, or shift over to Nova working through its print here. But yeah, it looks like it's dispensing quite nicely onto our substrate. We've got a great question around whether we're able to heat the substrate while printing for better sticking to the substrate. Nova doesn't have a heated bed feature in it, so we wouldn't be able to do that by default with the current vacuum module. But again, that's some great feedback. Yeah, there is some possibility for custom fixturing there as well, where you could come up with your own solution that integrates with that mounting grid from the plate I showed earlier, or beneath the plate. And we've also got some spaces on the sides for pass-through. So I'm not going to say straight no, but we haven't built a heating substrate solution at the current state. I've got a question around printing materials like silicone that aren't just flexible, but also stretchable. again, just silicone as a loose term is we would need a bit more information. So you can always reach out to us and ask about the specific material you're thinking about after the webinar, and we can take a look into it. We do have users that are printing with some silicone-based materials and getting great results. So yeah, it really comes down to the type of material. And again, if it's a material that is kind of listed as screen printable, there's a good chance that you'll have some success with it with Nova. Yeah, it sounds like a lot of you are interested in silicone, not just the material being printed, but also being printed on. So yeah, feel free to reach out to us after the webinar, and we'd be happy to navigate that with you as well. Yeah, and for those curious about kind of what defines screen printable, oftentimes you'll see on the label or the data sheet itself that it's listed as a screen printable ink. Since screen printing is kind of the standard for production flexible hybrid electronics, a lot of these materials just have that listed by default. So that's kind of what you want to be looking for. Giving a specific viscosity range can be a little bit misleading since how viscosity is tested itself, there isn't a kind of uniform standard across the board. So I'd be a little hesitant to give you a specific viscosity range. But again, feel free to reach out to you if there's a material that you're working with that you'd really like to dig in about, and we can navigate that with you. And we can see with our progress bar that we are getting close to wrapping up our print here. We're about, yeah, I would say about 80% of the way through. Yeah, and with so many of you in the demo today, if we've missed your question, feel free to email us at hello@volterra.io, and we'll get back to you that way as well. So yeah, if we missed anything, just reach out that way, and we can work with you. Awesome. So we have just completed our print. If we noticed right away that any feature was specifically missing, we could now would be a great chance that we could just select that feature specifically. So I can click on individual features to print. I might need to zoom in just because these are thin lines. There we go. Yeah, we can see it's selecting over there, selecting here, and we can select on just the feature that we want to print. But yeah, in this case, visually, it looks like everything's printed. So I'm just going to move to the inspection step, and we can use the camera on board Nova to take a closer look at our print. So I'm just going to swap to the background here really quick, and I'm going to move the camera right over top of our print. And let's get a little bit of a zoom in here, and we can take a look at how our print looks. I can adjust the step size by how much I'm moving the camera. Got some globs in a couple places, but overall, this is looking like a pretty good print. We're getting nice uniform traces. They're meeting up with our main contact points on either side. We've got a question around temperature. Can you set the ink setting to a different temperature other than 35 degrees? Absolutely. So yeah, you can just adjust it right here. So you could set it to 25 if you wanted, and then hit save. We just went with the default of 35 because it's going to be a temperature that really no lab is ever going to reach. So it's not something we have to worry about there. Awesome. But yeah, our print is looking pretty good, I think. And if we're having a hard time seeing the definition between our substrate and the background, we can also cycle through a couple different light colors as well to see if that helps us get a little bit better contrast. Yeah, that green is looking really good for seeing our traces. Can even turn the light off. That's looking pretty good as well here. Yeah, but I'm pretty happy with this print. Oh, I realized I wasn't even showing you guys. Yeah, so here's where we're inspecting the print. So I can move the camera across the traces, look for all of our connection points here. I can adjust the step size here that I'm moving the camera. And again, I'll toggle through the lights for you. Yeah, so we can see green looks pretty great for giving us some contrast between the substrate and our ink itself. Awesome, but yeah, I'm pretty happy with these print results, so I can click next. I can give the feedback that it went well. And then this is a great chance where if I wanted to do this print over and over again, I could save it right here. But yeah, in this case, I'm pretty happy, so I could hit finish. And you can probably hear in the background, the vacuum did turn off. I'm just going to home the tools so they get out of my way. And we can show the print up close to the camera here as well. And I'll just switch the camera here. And we'll see if we can get a little bit closer of a look. But yeah, there's our print. Yeah, we can see it looks really great to the eye as well. And yeah, this is something that we can go and do our curing in our oven. And then we would be able to stretch and manipulate this after laminating it to a material. I've got an example of a similar print here. So this is a piece of fabric, stretchy fabric, and this is the exact same TPU material and the exact same ink printed onto that material, but it's already been laminated to this fabric. And you can see I'm able to stretch it really far without any cracking in the ink. And yeah, it just returns. And yeah, we have the same conductivity no matter what happens with the stretch here. So yeah, really cool application of flexible hybrid electronics there. Perfect. So yeah, I think we've got a few minutes for questions that we can kind of work through the chat live as well. So yeah, feel free to pop them in the chat, and I'll do my best to see what's going on there as well. So we got a question about how do we clean the nozzle tip between the dispensing. So right now there doesn't seem like there's much ink on the nozzle itself, but yeah, there's a little droplet. So I could just take a wipe and just dab it across the tip of the nozzle. But yeah, it's looking pretty clean. Now, some of these materials do skin over a little bit, so sometimes you do need to just kind of purge the nozzle tip if you're stepping away for 20 minutes, half an hour. And you can do that by just jumping into the settings for the dispenser, setting a pressure specifically, and kind of just increasing it until we see that blockage go through, and then set it back to the default pressure there. to clear out the nozzle. So that's kind of the typical way for cleaning out the nozzle or wiping the tip. You can also use just like a Q-tip to get in there, maybe with a little bit of alcohol, and just wipe the tip off as well. Yeah, another question around the height map. Is it based off the initial mechanical probing? Yeah, that's exactly right. So that probing we did before printing on the calibration plate, as well as on our substrate, that's what's generating the height map for our dispenser to then use to offset the 40 microns that we set with our print settings. So it's using that exact height map for that. Yeah, so great question around post-processing. So how do we make the ink stick onto the substrate? Do you heat it after printing, or will it set at room temperature itself? This really comes down to the ink itself. All of these inks come with technical data sheets on how to post-process them. So oftentimes they're you can kind of find an ink for your application. So if you need something that's going to just cure at room temperature itself, there will be an option for you there. If you need something that you want to bake in an oven, that's going to kind of set you down a path on what substrate to choose and what ink to choose that way. The ones we use today, we can just pop in an oven and cure it that way. I think it's 120 Celsius is its cure, and the substrate safe temperature. So that's what we would do. And then we could cut it out and laminate it to fabric. Got a great question around, can we perform solder paste application and reflow heating similar to the V1? So that's a two-part question. So the application, absolutely. Solder paste is just an ink paste. It's screen printable. So Nova handles solder paste really well. But there's no heating element, no heated bed built into Nova. And kind of the decision behind that is we wanted Nova to be really versatile with a variety of inks, and we didn't want to just kind of choose one path. Heating is one method of curing, but there's tons of others like UV and UV curing, and yeah, just other methods. And so we wanted to make sure Nova was doing its best job at dispensing those materials. And we found most customers that are buying Nova have all their curing equipment already in their lab. And so they can kind of post-process the way they need to on the material they're using. So yeah, the recommended curing method for how we printed today, yeah, is just in an oven at I think 120 degrees Celsius. But yeah, if you were to use this for dispensing solder paste, you would need a hot plate or a hot air gun to then reflow that solder separate to Nova. So the max substrate size, if you're using the titanium vacuum module, is an 8.5 by 11 sheet. So that's what's going to fit in there really nicely. But we do have the pass-through on either side for larger substrates. So if your print area only fits in there, that's great, but you can kind of pass through the substrate on either side there as well. Placing components, yeah, again, Nova's designed for dispensing a variety of different types of screen printable inks. There's no, it wasn't designed for kind of pick and place or anything like that. So placement of components would be up to you again. So question around double layer. So there's a few different types of layering definitions. Yeah, currently Nova can do some minor stacking, but we haven't built into the software doing double layer with multiple materials like printing a conductive material and then a dielectric on top. But that is something in our roadmap. Um, So I think there's a question around the touch probing 3D surfaces. That's definitely in our roadmap. We've done some basic prints onto like the surface of a mouse before, and kind of onto a sphere, but it's not fully baked into the software yet. But that's something we're hoping to explore as well as Nova progresses. Yeah, so I think there's some questions around material handling and relaxation periods and all that kind of stuff. So, I mean, this is really comes down to material by material basis. The V1, we want to make things really plug and play. So we came up with our own conductor material and our own solder pastes that we know just plug and play work really well. So it's an all-in-one solution. Nova is really for you to explore different materials and figure out what is needed for your applications. So like there's a world of exploration that's involved with that, and exploring how your materials relax and how much resting period they need before being printed with is all part of that. So some of our materials we can pack and print the same day. So the material we were printing with today, the PE874, was packed this morning, and we were able to get some pretty good print results with it. But some other materials like the RD0142A that we ship with Nova, when we pack that, we wait a we go. I think I'm back. My headset just popped off for a second. Yeah, some questions around some substrates to print on, printing onto a copper or a cotton fabric, sorry. Yeah, it would really depend on the material and if that cotton fabric has a backing, and how thick the cotton fabric is, and how dense the fibers are. So yeah, it would really all depend there. Question around how difficult it is to achieve 100 micron dispense width. Yeah, it would really come down to the material itself. If the material is thin enough that you could print with like a 50 micron nozzle, 100 micron dispense width is very achievable for sure. Yeah, awesome. So yeah, I think we'll probably just wrap up the demo there. I think we've got some questions around pricing and all that fun stuff about Nova. Feel free to just jump right on our website. We've got the pricing available there, and you can reach out to our sales team, sales@volterra.io, and the website is just volterra.io. And yeah, reach out to our sales team. Ask some questions, figure out if Nova's right for the applications you're looking for. And of course, you can also reach out at hello.volterra.io if you're not sure where your question should be headed. And if you enjoyed today's webinar, we're doing another one in about a month. And we'll be sending out the link for that webinar with the recording of this video in an email tomorrow to everyone who attended today. So yeah, and if you just missed both of those things, we'll be posting about it on our website and our socials as well in the coming weeks. So just stay tuned for that. But yeah, really appreciate everyone joining us today for the demo. And yeah, look forward to chatting with some of you. And yeah, again, that's hello.volterra.io. Or sorry, I said hello.volterra.io. It's hello@volterra.io. Awesome. Have a great day, everyone. We'll chat to you later.